Welcome to CW 5.3. Let's start with our first example right here. Evaluating trig functions, let P equal this point on the terminal side of theta. Find each of the 6 trig functions. So whenever you have a question like this, the setup is always going to be the same. You always have to draw a triangle. And hopefully you remember the basics of trigonometry with SOHCAHTOA. So sine of theta, that's O over H. Cosine of theta, that would be A over H, and tan of theta would be O over A. So let's first start by doing our picture. So here's our xy axis, the point -3, -5. We know that would be in quadrant 3. And what you want to do is just draw a triangle, like that. And if this point is -3, -5, what you want to do is label the legs of the triangle and put theta right there. Notice how I'm putting a negative here. That actually is important. So in trigonometry, these triangles are a little bit different from a regular triangle. This leg doesn't mean that the length is -3, because that really wouldn't make sense. This is the x component and the y component, which means they do have the possibility of being negative. So that's why it relates more to the x value of the coordinate or the y value of this coordinate than the actual leg of a triangle. However, the hypotenuse, that actually is a distance, so this thing will actually always be positive. So again, you gotta remember that the legs of the triangle, these are components, can be negative. Hypotenuse, that's always gonna be positive, but also that'll happen anyway when you do your math because you're gonna square everything, the Pythagorean theorem. So do Pythagorean theorem and you're gonna get the square root of 34, and now we can evaluate everything. Let's write our trig functions here, sine, cosine, tan, then cosecant, secant, cotangent. And notice how I'm writing it in this order because I want the reciprocals to line up nicely there. And now let's find everything. Sine is O over H, so that's -5 root 34 over 34. Cosine, that's A over H, so -3 root 34 over 34. And tangent is O over A, so 5 over 3. Now keep in mind when you do the reciprocal, you wouldn't want to flip this thing because that'd be pretty rough to do the reciprocal. So understand that cosecant is simply h over o. So now I can see h over o, that's negative root 34 over 5. By the same logic, the next one is negative root 34 over 3, and cotan is obviously 3 over 5. Next example. So tan theta is less than 0. So convert that to our knowledge of the circle. The ratio is less than 0. Cosine is greater than 0. So x should be greater than 0. Where are we? So draw your grid. If x is positive, that means we can actually eliminate quadrants 2 and 3, because that's where x is negative. And the ratio is negative. But if x is positive, you can conclude that y must be negative, because the ratio is negative, which means it's not quadrant 1, so it gotta be quadrant 4. That's how I do that one. Next one, given tan and cosine, find cosine theta and cosecant theta. So this is actually quite similar to the last question, except now it gives you actual numbers. So it says tan is negative, cosine's positive. So again, if cosine's positive, that means we don't want any of these because x is greater than 0. And if tan is negative, again, we must be in quadrant 4. So draw a triangle in quadrant 4 like so. Now here's the important part. The ratio is 2 over 3. And notice how it's negative. You would not put the negative here because this is the x component and x is positive on this side of the axis, which means the negative must be on the 2. And that's your y component. Pythagorean theorem, that's root 13. Theta is right there. And now I can figure everything out. Cosine should be 3 root 13 over 13. And cosecant theta should be root 13 over negative 2. Okay, 2 more examples. Reference angles. Hopefully that is somewhat familiar. You probably forgot how to do this. So the definition of this reference angle, it's quite simple. It's simply the positive acute angle with the x-axis. So the 2 key things here, positive and acute. As long as you got that, you're good to go. So 345, you rotate 345 degrees. That's right there. The reference angle is this little bitty piece right there. So think about it. If 360 is right there, subtract them. The reference must be 15 degrees. 5 pi over 6, that's right about here. So that's your rotation. The reference angle is that little piece right there. And if this is pi, the difference should be pi over 6. Next one, negative 135. So you're going to rotate down right there, negative 135. And again, the reference angle is the positive acute angle with the x-axis right there. That has to be 45 degrees. And the last one, this is kind of tricky. It says 2.5. Notice how all of these have like degrees for A and C. This one is clearly a radian. This one is also a radian because it doesn't say any label. So we can assume it is a radian. So 2.5, that's going to be right about here. And you're probably wondering, how did I know that? So that's because I know 2 radians, that's approximately 120 degrees. Because I know 1 radian is about 60 degrees. So I know it's a little past 120. So the reference angle is that little piece right there. And if this is 2.5, the little piece right there is going to be pi minus 2.5. And right there, that's our reference angle. Okay, next part. So it says use reference angle, so we're actually not really going to do that. We're actually going to use coterminal angles to figure this out. So meaning I want to take off 12 pi over 3, because 12 pi over 3, that's equal to 4 pi, so I want to remove those rotations off. And I got 10 of 2 pi over 3. Now we practice our unit circle method. 2 pi over 3 is right there. That's going to be large negative for tangent, so negative root 3 is our answer. For this one, we're going to do the even odd property. Secant is even, which means a negative doesn't matter. So you can make a note there, it's an even function. Let's cross that out. So now I have secant of 17 pi over 4. I'm going to subtract 16 pi over 4, since that's 4 pi. And I'm left with pi over 4, which is much easier. That is root 2. Since I'm looking at the middle value, and cosine of pi over 4, that's root 2 over 2. Reciprocal, root 2. And we're done.